Hi, my name is Nathan Pallo, and today I'll be showing you how to replace a broken gallium nitride chip scale transistor. So what I'm going to be doing is using hot air to remove the damaged switching cell, clean the pads with a soldering iron and solder wick, and then I will take the cleaned switching cell with the depopulated transistor and put it in the Fine-Tech machine where we can install a new gallium nitride transistor. First thing we do is fixture the PCB that you want to do the rework on. Once everything is firmly in place and well accessible during the entire process, I'll turn the hot air on. The hot air will reheat the solder underneath the gallium nitride transistor, and once it gets to the right temperature, the temperature of the eutectic, the solder will become liquid and I can pull the transistor back off of the PCB. So once I noticed that the solder has become more liquid, I can just gently tweeze both sides of the device, pull it off, remove heat from the board, turn off my hot air, and let the board cool down. I'll be using the solder wick and an iron to remove the solder that's still left on the board by the broken transistor. So I will apply flux to assist in wicking up the solder. The solder wick does also have flux embedded as well. And to wick the solder off, I'll put the copper braid on top of the pads and apply the iron, being careful not to wipe with too much pressure, while this board way that the pads can withstand rework. Applying too much pressure as you scrape across with the iron can actually ruin the pads on the circuit board. I'm also being careful not to touch the other components on the circuit board with the hot iron. Ceramic capacitors, also located on the board, in particular, are sensitive to thermal shock from being touched with a hot iron. You can get a nice view of all of the pads and see that most of the solder that came from the old broken device has been removed, and I can clean this PCB in preparation for the new device. And that was the removal process.